Okay, we are recording. So today is a really big day. Today is the last day of this book, and we're gonna finish with a banger chapter. We're gonna finish with doesn't quite the same level of quality without a name, but pretty close. And we're gonna talk about economics. We're gonna talk about economics, and we're gonna also talk about non-intuitive market behavior.
Indeed.
So it starts by saying, well, the title is Money Through Innovation Reconsidered. I'd guess that fans of capitalism generally believe that innovation is the critical success factor and that natural evolution derived from competition makes the world better for consumers. Every word of that belief is true, but the assumed meaning is not. Rather, the assumed meaning is that companies are rewarded for their innovation, where innovation means invention. That the more innovation, the better. That consumers get a better world by leaps and bounds. And that is what we're going to be talking about, essentially. Um, and then the first thing that Gabriel is going to try to distinguish is that there is a difference between innovation and invention. Innovation means to change a thing into something new, to renew, or to introduce something for the first place into the marketplace, into the first time into the marketplace. On the other hand, the backing piece refers to innovation as a stream of new ideas. But even in innovation, there is a degree of improvement implied by alter or make new, which is the root meaning of the word. I will adopt the term radical innovation to mean innovation based on new ideas rather than on incremental improvements to known ideas. Yeah, so I think this is pretty like this is a core, a fundamental principle of what he's going about to say, which essentially means that these people, these people, they are underestimating the weight of inertia. And inertia, in our context, means incremental improvement. So instead of being completely radicalized and we go to completely new grounds and new waters and unseen shit, we're actually doing improvements on something that we did before. So that's pillar number one. Pillar number two is the thinking that innovations causes the world to greatly improve for consumers. And then his thesis is simple. Invention, radical innovation, and great leaps forward do not produce revenue commensurate with the required effort in the software industry, and invention usually doesn't work in any industry. So the most, I guess, the most consumer-ish tech gadget that recently suffered from this are foldable phones. So have you heard of those, Mari?
Foldable phones, not really.
Yeah,
Are they like a mashup between our current smartphones and the old flip phones that
yeah,
you could fold?
yeah, yeah. And
That
that's
sounds kind of neat because I think flip phones are neat, but how does that even work?
well, you make glass bend.
But okay, assuming you get that to work, don't you have issues where you have glass against glass where that can scratch?
No, because you make the surroundings of the phone a little bit with bumpers, so when they do this, they actually don't hit each other. The glass.
Okay.
And it is a little bit of a stretch what they did because it's not really glass, it's glastic, which is a mix of glass with plastic. So
But
it's not.
like,
Go on.
why would you even do that?
Well, it's obvious. It's because you either have a tablet that fits in your pocket, or you have a phone that fits in any pocket.
I see, so they want a tablet that's the size of a phone when it's not in use, essentially.
Yeah, and that's the closest thing that I would call in the smartphone industry as a radical innovation. Um, the answer is then, did it work?
I'm guessing not, since I never heard of it.
Well, it depends on the definition of work. But did it get popular? No. Did it get cheaper? Yes, but not to the point of being a commodity that anybody can buy. Um, so if you consider that a failure in those terms, you can say it's a success because you're in the seventh year in a row deploying foldable phones to the world. Um, but I would say that the revenue commensurement for that the engineering required, pricing related, so the amount of engineering and moving parts and new technology that was required to make this effort, it didn't produce the revenue stream that it's required to make it popular. So that's kind of what he's saying. I mean, that makes sense. Before we get to general abstract, let's look at some examples. Starting with Microsoft. First, as the economist points out, Microsoft didn't even own DOS when it sold and did not invent it. Moreover, at the time IBM innovated with MS-DOS, its technology, well, innovated means introduced to the marketplace. Its technology was at least 15 years old, perhaps older. Even if you look at Windows 95, which is just coming out as I write this, the newest ideas in it date from the mid 70s, and the core of it is still rooted in the inventions of the 50s and 60s. Windows 95 is an innovation in the true sense because it is a renewal of those old ideas in the current context and contains some improvements over them. Yet the ideas are the same. It contains no stream of new ideas. So again, we're talking about non-radical innovation. We're talking about improving the old, and that's gonna matter for later. Um, blah blah blah. In short, there are plenty of reasons that Windows 95 is good for consumers, but few of those reasons have to do with invention or radical innovation. I believe Microsoft is pursuing the correct strategy for a technology company, but this strategy has nothing to do with invention, radical innovation, creativity, or imagination. And then we go to another example, which is Unix. And then he talks a little bit about the history of Unix, right?
Right.
Blah, blah, blah. Well, this is basically how Unix was originated, and then Unix is the default workstation operating system now. When Unix first came out, there was nothing inventive about it. In fact, in some ways, it was poorly engineered. A good example of this is the PC losing problem we encountered in the essay The End of History in the Last Programming Language. The PC losing problem occurs when a user program invokes a system routine to perform a lengthy operation that might require significant state, such as I/O buffers. Yeah, this is talking about state management, right? With interruptions, I guess.
Yeah, if you have a program that does a syscall, but the machine gets an interrupt, like say from a input event, like you hit a key on the keyboard
Mm-hmm.
during the syscall, what do you do? Because you're in the middle of a syscall, you have state that belongs to the operating system, not the user program, right?
Yeah. And talks more about that. And in in the 80s, if an interrupt occurs during a system call, the call will immediately complete and will return an error code. The trade-off was made that the simplicity of the interface to the system would be sacrificed so that implementation simplicity would be preserved. Yeah, this is a foreshadowing of something that we're going to talk. Well, we already talked about before about the worse is better philosophy. We're going to talk more about it here. And this is the beginning of it all. So the simplicity of the interface being sacrificed by the simplicity of the implementation. Which, at least in my opinion, it's completely reversed in terms of my priorities. So When you're developing a new feature, Marinho, what is the first question that comes into to your mind? Any feature.
Any feature. How is it going to interact with the rest of the system?
Okay.
What's the interface essentially?
My question is how it's going to look like. I try to imagine a world where I can imagine any series of tokens, and I try to confabulate how the feature is going to look like. Literally from a top down approach. So I imagine first how it's going to look like when somebody's using it. So, I'm making a checking system for some requirements of an endpoint. Okay, how that's going to look like? How would I like that to look? What would be the best way to interact with this? And after that, I think on how I'm going to do it. Here, we are talking about the opposite. We're talking about how I'm going to do it and how we will use it. It's a second concern. And I don't know. I don't know when exactly in my life I decided to do this priority queue, but I do.
Hmm.
And it happens naturally. It's not something that I am on purpose thinking about. I'm not thinking, oh man, I'm so cool, FP's interface first, blah blah blah. I'm not doing that. It just naturally comes to me like that. And I don't know. I really
Hmm.
don't. Uh, to me, it makes more sense to think the opposite of the. Well, this is the worse is better philosophy, so I'm not exactly surprised, but it's kind of funny that I naturally concluded the opposite. Uh,
I don't know. Sometimes I think about the interface first, sometimes I think about the implementation first. I don't really have a standard.
I do. And again, I'm not making this like thinking about it, like on purpose. It's just naturally. It matters way more to me how I'm gonna use it. Yeah. And I think I have an hypothesis on why. It's because when you think about how you're gonna use it, you are thinking about the ergonomics and you're thinking about the mass that's gonna be exposed. And I rather have mass centralized in a particular place, but if the mass is contained within a function, for example, if the interface is great, I can literally use the function everywhere and keep the mass in a single place. If you do the other way around, the clean part is in one place, but the mass is in many places. So yeah, trying to rationalize my how I think, that's one hypothesis that I have. And therefore, the implementation could be easily checked. Wait, therefore was made that the simplicity of the interface of the system would be sacrificed, so implementation simplicity would be preserved, and therefore the implementation could be more easily checked for correctness. Programmers must insert checks or error codes after each system call to see whether the system call actually worked. It might seem odd that one would write a system call and then have to explicitly check whether it worked. It returned, didn't it? But Unix doesn't need that 60 or so pages of complex and probably incorrect assembly language that backs out of every system call. And therefore, it was easier to make Unix portable. Unix was simpler and smaller. Unix shows implementation simplicity over interface simplicity, whereas ITS shows interface simplicity. As you might suspect, many Unix programs were incorrect because after an interrupt they would crash. But Unix is an operating system that is still in existence and ITS is not. That's evidence. That's historical evidence.
Out of curiosity, do you even know what ITS means?
No, But it was new, I think.
It's the incompatible time sharing system.
Damn, what a name. Uh, well, we have more examples of this pattern in the industry. Japanese automobile manufacturers started by producing low-cost, moderate-quality vehicles for sale in the United States. As they were accepted, the manufacturers upgraded their product lines with improvements. Yeah, so there is a trend here going on. You start with something that is particularly mediocre, and then later on the line, after the flux of money kicks in, you start to improve on it. My criticism of Gabriel's analysis is that he's missing the risk of this move, which is who said that after the money kicks in, you're gonna be able to pay for the fix that you did temporarily, that the hack that you did temporarily to launch it. Who said that undoing the ugly way and doing the right thing is affordable? Who said that's cheap, and who said that you're always going to be able to pay that cost? Because the way that they are saying here, upgrade means like an easy thing. It's just an upgrade. I don't know. You do a Nix Flake update, and everything works. But that's not how that goes usually, huh? So my start of the criticism of this chapter is particularly about this lack of analysis of the risk. You cannot always do that. You may die, you may go bankrupt trying to do it. Because sometimes not doing the right thing and then deciding later to do it, it's unaffordable.
The point is that you're not going to switch to the right thing, actually.
Well, but so this upgrade, it like well, let's proceed to
It's
the
an
right thing.
increment. The upgrade is an incremental improvement over worse is better, which is still worse is better. It's not the right thing. It cannot be the right thing.
But that's not what I understood from the conclusion at all. My understanding, we're gonna get there, is that the conclusion is that you need the worse is better for the bootstrapping phase for many reasons, but one of those reasons is because, in particular, because the worse is better is less frightening. It has the inertia. It has a little bit of the inertia. So if I'm saying that I'm making a system in C, and some amount of people will be okay with that, but if I say that I'm building my system in some what weird X32 assembly from the 90s or whatever, people's gonna look weird at me if I say that. Even if my assembly is better than C, even if it's the right thing, it doesn't matter the being better. There is a factor that I was not counting before, even though I read worse is better, that the inertia matters not only because we already have developed a shit ton of things in C, but it also matters because people are more used to C. So it's a double factor on the inertia actually, not a single. Oh man, we already have a bajillion lines in C. We're not going to rewrite all of that. Come on. It's not only that. My understanding would be that we would eventually go to the right thing after we bootstrap. But your understanding is
Why?
that you never would do that. You will never do that.
Well, C is still around, no?
No, but um, you are assuming that they will actually reach the right thing, right? I'm actually saying
No,
that
I'm
that's what they
I'm
want.
not. I'm not actually. Like you start with the worse is better, and then you keep incrementally improving it. But if it turns out that the right thing is actually fundamentally different from what you got from when you started from worse is better, you can't make that jump incrementally. So actually, you are never going to the right thing.
Yeah, but you are making a big if in there. You're making an if that that the wrong thing is a fundamental thing, right? What if it's not really like uh,
Let's take the Unix
database
example.
design? Sorry?
Let's take the Unix example. You can't change from, okay, I'm actually going to correctly preserve the state of the system if there's an interrupt during a system call. If you do that to Unix,
Everything breaks.
it's not Unix anymore.
No, yeah, but again, you're grabbing examples at the core fundamental problems at the core of the implementation. Let's pick my example, database design. You're not swapping the BMS. You're still using the same tool, but the design may be with a bunch of news and may be fucked in launch. But you know that Postgres is capable of doing things a little bit more properly. But that's the catch. Even if you know that, and even if you want that, it doesn't matter because in the case of a huge database design, a flawed database design, you may not be able to afford that, even if you want it. And that's my point, is that not all the time the worse is better philosophy is like a parasite that you cannot get rid of, such as C or Unix. Sometimes the worse is better is actually a little bit more subtle, and it actually lives on the design decisions and the architecture decisions. But even those decisions you may not be able to afford to make it right, even if the tool is the same. And I'm not here to defend Postgres. You know what I think. It was well known in the 70s how to make excellent quality cars with lots of features. But the approach would have resulted in minimal acceptance. No one wanted to buy a luxury car or even a regular car from a company named Toyota or Nissan. But they might want to buy a minimally equipped, moderate quality car at a low price. The pattern is to get something of acceptable quality into the largest marketplace you can and then later improve it or add a narrow focuses with higher quality, more inventive products. Today, many people look first to Japanese automobile manufacturers for luxury cars, as well as for cars at all levels for quality and features. And then we go to the worse is better philosophy. So this is the worse is better philosophy. Simplicity. Design a simple implementation. The interface should be simple, but anything adequate will do. Implementation simplicity is the most important consideration in the design. Completeness. The design covers only necessary situations. Completeness can be sacrificed in favor of any other quality. In fact, completeness must be sacrificed whenever implementation simplicity is jeopardized. The design is correct in all observable aspects. The design is consistent as far as it goes. Consistency is less of a problem because you always choose the smallest scope for the first implementation. So we end up with implementation that should be fast, it should be small, it should interoperate with programs and tools that the expected users are already using. Okay, again, the whole inertia thing. It should be bug free if that requires implementing fewer features, do it. And it should use parsimonious abstractions as long as they don't get in the way. Abstractions get in the way when it makes implementation too hard, too slow, or hides information that shouldn't be hidden. It is far better to have an under-featured product that is rock solid, fast, and small than one that covers what an expert would consider the complete requirements. So essentially, um, how to put this in simplest words? Simpler words. It should be as dumb as possible if that's enough to make it work. I think that's fair. Do you think that's fair?
Keep it keep it simple, stupid. That's the motto, I guess.
Yeah. And here are the benefits. It takes less time. It takes less development time, so it is out early and it can be adopted as a de facto standard in the new market era. It is implementally and functionally simple, so you can run in smallest and smallest computers. Easily portable. If it has some value to be ported adopted, like a virus model, so it will spread like crazy. If it has value and becomes popular, there will be pressure to improve it, and over time it will acquire the quality and feature richness of systems design another way, but with the added advantage that the features will be those that the customers or users want, not those that the developers think they should want. And this is actually true. I didn't think of that the first time, which is that if you have an incomplete thing but upgradable, you can bootstrap it first and decide what to upgrade later.
Yeah, that gives you a degree of flexibility. I think that's kind of the point, right? Of the whole worse is better thing. It's about flexibility at the end of the day.
Yeah, but we are doing a trade of correctness to get that flexibility, right?
No, you are not. Go back to the principles.
Design is correct in all observable aspects.
Yes,
All observable aspects. Not all correctness is observable.
not all correctness is observable.
Yeah. So if I give you an insert function for for SQL in Postgres, from an API perspective, observably, you don't know if the tables are full of nulls or if I'm giving you a updatable view. Doesn't matter. And it shouldn't matter. For this particular case of the API is the same. It's your job as a DBA to make it the best as possible. But from the perspective of observability, from an API perspective, it's the same shit. I'm looking. There are columns. There are nulls. Are the nulls coming from a table? Are the nulls coming from views? Who knows? So to me, this is the caveat. You're not making things right 100%. You're making it as right enough. Uh, cool. The path of acceptance that the worse is better system is placed in a position in which it can act like a virus spreading from one user to another, providing tangible value to the user with minimal acceptance cost. It can run everywhere. There are no artificial barriers. The system can be improved by end users because it is open and openly modifiable, and its implementation is simple, habitable enough that users can do this. The simple implementation provides a means for the originators to improve the system over time in a way consistent with how it's being used, thereby increasing the magnitude of the most important evaluation factors. Over time, the system will become what lucky developers using a more traditional methodology would achieve. Yeah, that's what I meant by saying that it seems that they want to achieve with the benefit of being already be able to bootstrap it, they want to assume something similar. That's why I remember that. This may seem counterintuitive. Many people believe that being competitive requires doing the absolute best development you can. And then this is the philosophy that he's calling the right thing. The design is simple, both in implementation and interface. Simplicity of implementation is irrelevant. Just let that sink in. So you can have a mess, you can have whatever is required to make it fast and work under the hood. That's not really the goal. Well, that is the goal, but if we don't reach it, that's fine. The design covers as many important situations as possible. All reasonably expected cases must be covered. The design is correct in all observable aspects. Incorrectness is simply not allowed. The design is thoroughly consistent. A design is allowed to be slightly less simple and less complete in order to avoid inconsistency. Consistency is as important as correctness. There is really only one implementation requirement. It should use hard abstraction throughout. Elements must be properly encapsulated in order to achieve information hiding. Yeah, I don't know. This sounds more like an OOP requirement to me. What do you think?
Yeah, I agree with that. This one point is kind of weird. Feels out of place, to be honest.
Feels out of place, I agree. The acceptance path for a right-sync system is that it is the right thing off the bat, and even though it came late to the market, it is so wonderful that it is quickly accepted. Of course, it has to be on every necessary platform either right away or quickly. This scenario can happen. It is simply unlikely. And then we have the Macintosh example as one of the candidates of the right thing philosophy. And that did some market share. We can still see the, the the consequences of that today. Um, yeah, I think we should read this. The difference between what happened to DOS and the Macintosh is the example of what is known as gambler's ruin. Suppose two players have equally large piles of pennies. Pick a round number like a jillion. If the players have a fair coin and flip it, with one particular player taking a penny from the other if heads, vice versa if tails, what would happen? It would seem that the players would keep their positions as roughly equal amounts of pennies. But in mathematical terms, this is an event of measure zero. It will never happen. The probability is essentially 1 that one player will lose all of his pennies or her pennies. But if one of the players starts out with more pennies than the other, the probability that the player will end up with all of them is equal to the proportion of that player's pennies to the total number of pennies. This makes sense, right? This makes total sense. There is a tendency to think that somehow the free market is fair and that all seemingly fairly matched competitors will survive. If there is some aspect of a business that involves consumer resources used in competition, that business is subject to gambler's ruin. And that is one a very interesting insight. Because this essentially means that it's impossible to have a fair competition, right? That's what this means.
Well, define fair to begin with.
Well, statistically speaking, equal chances.
Yeah, that's not gonna happen.
Yeah, but it's now we have even more clear that it's never going to happen, particularly because the consumable resources are never going to be the same. In the case of PCs versus Macintosh, the PC DOS player started with many more pennies in one. However, there is more to it than chance. The Macintosh was clearly superior, yet it lost. Among the reasons for losing was that Apple didn't license its technology until 95, so that a clone market didn't appear earlier. There are other problems stemming from the difference between the two philosophies. One is that MS-DOS provided a simpler, more malleable base so that the aftermarket could more easily mold MS-DOS to what it needed. One of those characteristics of improvement were known. MS-DOS evolved. Yeah. One of the obvious criticisms of worse is better is that there is something worse going on. That is something not good or not right. It seems like the idea is intentionally to put out an inferior product and hope that things go well. This isn't the case. But even if that was the case, uh, but this argument can still be attacked. When you say that a system is inferior to what it could be, you are basing the conclusion on an evaluation criterion. Necessarily, you are using perhaps intuitively a metric based on a projection. That is, no one can evaluate an entire system over its use settings. So you are looking at either only part of the system or some of its settings. That is a projection. And then the problem is that you can choose whatever projection, right? Like
Right.
that makes sense. You can use a bias projection. You can use I don't know, a random projection. Doesn't really matter. Um, and you can also choose a criteria that is not valued by the users. So it's a lose-lose situation, right? because you need, if your audience is dumb, you cannot do anything about it, right?
That's kind of sad.
I'm not saying that people don't like Modulo 3, they are dumb. I'm just saying that if that happens, you, from a company's perspective, you either convince them that they are dumb, and good luck with that, or you need to create a product that the dumb people value. In this case, a programming
Like,
language.
like Python
Hot takes, boys.
or JavaScript.
Uh, in the modern era, we have come to favor simplicity over complexity, perfection over imperfection, symmetry over asymmetry, planning over piecemeal growth, and design awards over habitability. Yet, if you look at the art we love and the music, the buildings, towns, the houses, the ones we like have the quality without a name, not a death-like morphology of clean design. In many cases, the software system that seduces starts with a kernel of good technology, but is not committed to fully to realizing the technology. By enabling users to live in the implementation to some extent, or to mold the technology to users' needs, while dropping hurdles to use to uh, while dropping hurdles to the use of the technology, that system is able to survive and evolve. So yeah, this is the paragraph that I was waiting for. The right thing philosophy is based on letting the experts do their thing all the way to the end before users get their hands on it. The thought is that until the whole grand structure is built and perfected, it is unusable, that the technology requires an expensive demonstration to prove its effectiveness, and that people are convinced by understanding the effectiveness of a technology as if we needed to know that vehicles based on internal combustion engines could carry immense weights, tons and tons, or seat dozens of people before someone would be willing to buy a four-person 15 horsepower car. This paragraph, in its entirety, reminded me of Jai. Like, the first thing that came to my head when I read this paragraph was, this is the game that Jonathan is playing. This is it. This is exactly what he's doing. This is why Jai is closed source. This is why there is an open beta for a decade. He believes that he should have the thing perfected and ready for everything, ready to demonstrate that, ready to put C++ into its grave.
Ready to be a freight train before people can buy a car.
Exactly. He's he's he is developing something that he thinks has the potential to kill C++ for real, for game development. And he's only gonna launch it when he thinks the package is ready. And the only people that he believes has the expertise and the good taste to help him with his mission is himself and the people hired directly by him. This is the game he's playing, man. Like, this is a one-to-one description to what I understand he's doing.
Yeah, I can see that.
And you may say, well, that's a little bit arrogant, right? How can you say that the only few individuals in the planet that can have are worthy of participating in this endeavor are the author himself and whoever is being hired by him? Well, the evidence that Jonathan usually brings to the table is that open source methodology has the benefit of contributions, but it doesn't guarantee the quality of them or the vision of them.
Well, an open source project doesn't have to accept contributions.
No, it doesn't. But if you're not accepting contributions and it's open, you're generating noise to yourself.
Why? Can't you just ignore things?
That's easier said than done. That's easier said than done. The so that was his choice. To his understanding, like again, that's my understanding of what Jonathan understands based on what I watched him and a few hours of videos and some clips. He doesn't trust this process, which is understandable given the evidence that he brings to the table. He gives examples and something that was working before. Open source stuff happened and then it got worse. And then you look at the code, you see that the code also, according to him, got worse. So he trusts himself and his decision making to hire the right people. And I can understand that a little bit. Like I don't think I am that great, but I can understand the sentiment that we need the right people to do this. It's not something that will fulfill its full potential if it's open in the wild. Anyway, I talked a lot about this paragraph, but it's because again I had to do this mentioning. Worse is better takes advantage of the natural advantages of incremental development. Incremental development satisfies some human needs. When something is an incremental change of something already learned, learning the new thing is easier and therefore more likely to be adopted than is something with a lot of changes. To some, it might seem that there is value to users in adding lots of features, but there is in fact more value in adding a simple, small piece of technology with evolvable value. And the only way to get around this problem is by doing an impressive, like, um, massacration, doing an impressive demo of like, this is how we do it, this is how I'm proposing for us to do it, and I'm gonna let you be the judge. Like,
Yeah.
the goal of a software enterprise is to make it into mainstream, and being in the mainstream does not mean selling to a particular set of corporations. It means selling to customers with particular characteristics. And then we go to another very interesting insight. The the market, one of the key characteristics of the mainstream customer is conservatism. The customer does not want to take risks. That's why the first foldables were not a success. Like even in any definition, they were not a success. That's why, even though they are probably losing money, they needed to make the price lower to make it more seducing for people to try to buy the risk of using glass instead of glass, of being able to fold and to be able to have a tablet in your pocket. He doesn't want to debug your product. He doesn't want to hit a home run so he can move up the corporate ladder. Rather, he wants known, predictable improvement over what he's doing today with his own practices and products. He wants to talk to other folks like himself and hear a good story. Like, like this is essentially saying that an echo chamber thing must happen, right? This is kind of
Right.
saying uh, your odds of going against the current and winning are very low. That's why, again, you must have some balls, man, and you must say, I let you be the judge. Here's the now. Here's the future. Judge. And the improvement needs to be out of this world. Uh, he doesn't want to hear how someone bet it all and won. He wants to hear someone bought the product expecting 10% improvement and got 11. The customer is not interested in standing out from the crowd, particularly because of a terrible error in his organization based on a bad buying decision. These aren't the characteristics of someone who would love technology and build an extravagant product based on it. Therefore, it is hard for technologists to understand what this customer values. Because as nerds, as we are, we want to be pushing for the bleeding edge, and we don't really care about, oh, this is too different. Fuck that.
Lisp and Prolog beg to differ.
The ideal of the free market supports this kind of growth. If you decide to spend a lot of resources depending on developing a radical innovation product, you may be throwing away development money. Why bet millions of dollars all at once on something that could flop when you can spend a fraction, test the ideas, improve the ideas based on customer feedback, and spend the remainder of the money on the winning evolution of the technology? If you win, you will win more. If you lose, you will lose less. Moreover, it will be you will be out there ahead of competition, which is happily making the right thing mistake. Microsoft won by putting out junk with a core good idea, and usually not their own idea, and then improved and improved, never putting out something too innovative, too hard to swallow, too risky.
I'm not sure if that's a compliment or a criticism.
This is definitely a compliment, but given that it's worse is better, being junk doesn't matter.
I'm not sure if that's a compliment I would like to receive, you know?
Well, did you create a product that is being used for decades? If
Nope.
you, this is the same, like, in a way, if you want to extrapolate, this is the ends justify the means. Again, worse is better is a, a facade, a piece of clothing in which the user of this clothing is the ends justify the means.
Hmm.
It doesn't matter that it's junk, that it is not even your idea. Doesn't matter because the end is surviving for decades. It's going to the mainstream. Worse is better is kind of an implementation in software of the philosophical statement the ends justify the means.
Hmm.
It's brilliant, man. It's it's something else. Like this guy, come on. Uh, okay, what else? Yeah, then he's explaining more and more about the benefits of doing small little improvements in comparison to doing a big batch of new stuff.
You know, this thing about charging for each incremental improvement, doesn't that remind you of DLC on games?
Well, in in these terms, we are old. So back in the day, DLCs they were actually a little bit they were packed with content. Today, with gaming as a service, it's actually small for real. We are talking about, oh, you can buy this new clothes in the shop or something.
Yeah.
Back in my day, when we're talking about DLC, we're talking about like, oh, I actually can play more, wait, like 100 more songs in my Guitar Hero game. I can actually play more maps in different game modes.
I, I actually have an entire new campaign in Warcraft 3.
Yeah, exactly. So I think for our standards, that's those are actually huge improvements in comparison to today's standards. With incremental improvement, the lifetime of an idea can be stretched out, so you don't have to keep coming up with new ideas. Yeah, so it even has this benefit. It is naturally recyclable. Huh?
Yeah.
It removes the burden of innovation. Because innovating and being creative is hard as fuck. So, but this worse is better also removes that from the play. It's insane. Man, it's insane. Who wants to base one's economic success on the ability to come up with new ideas all the time? Because having new ideas is hard. And it is. I'm not saying that ironically. The free market means improvement for the consumers, but at the slowest possible rate. And companies that try to go faster than the rate are almost always hammered down or killed. On top of these factors is the feedback loop in the free market. For some reasons, it makes business sense to make small improvements rather than large ones. Because companies use these techniques, the patterns established at the free market go slowly. Given that, consumers now act in accordance with the free market. For example, because consumers rarely see radical innovation, it's too expensive, and a series of incremental improvements seldom, if ever, amounts to radical innovation, they suspect its value. And so this is actually another minus for the innovation folks, the radical innovation folks. People are not only scared of something that is radically new, they are also skeptical about it. So, like, look at how many forces are playing against you, man.
Yeah,
So you have the force saying that the old is known, so it's less risky, and you already know it. We also have the the fact that if it doesn't look similar to that, there's another vector of force going against you, and now there's this skepticism of that. All of that going against you, all of that at the same time. You might say that consumers are conditionally by the free market against radical innovation. Like look at this phrase, man. When you add the risk aversion of the mainstream marketplace to the minimal innovation forces by the free market, it is easy to see that the right thing is just too risky to try unless you are really sure it will work. And again, balls, balls. But in the case
yeah.
of Jonathan, his competitor is C++. Like the bar is not that high. So I think he really has a shot on this. Like regardless of what I said about in the previous paragraph there, I really believe he has a shot on this, which is gonna be so freaking hilarious, given that a Lisp guy predicted what he would do decades before, and I don't even think Jonathan likes Lisp. So that's gonna be
That's kind of
hilarious.
that's kind of sad.
Um, yeah, there are many hot takes that Jonathan talks about, the stuff that we like. Lisp is only well, I never heard. I'm only guessing that he doesn't like Lisp. I never heard of him saying about Lisp. I heard of him talking shit about denotational semantics, though, and that was very heartbreaking. But anyway, and then we go to the Lisp example. In order for Lisp to succeed, as Lucy promoted, the customer would have to buy into AI, buy into using an unusual language, buy into the peculiar development environment with its own code construction, debugging, maintenance tools, and accept the view that the standard computing world was at the other end of a narrow forming function interface. It is too much to ask someone to accept when the value to the customer is a simple rule-based computing paradigm from AI and incremental development from Lisp. There is no reason not to have presented expert system technology in more familiar surroundings or to introduce incremental development using Lisp, considered more like a traditional programming language.
And the
Yeah, even
example here is obviously Clojure, of course, because Clojure is like it's kind of like Java in the sense that yeah, it uses the same calling convention, so you can just straight up call Java directly. Like there's no FFI at all.
yeah, but I don't think that's what he means by a Lisp constructed more like a traditional programming language. I think he's going. I think he's going deeper than that. I think he's talking about changing how it looks even.
That's very superficial, Lemos. Although there has been an attempt at that. Have you ever heard of Dylan?
Uh, Before we go into that, it is superficial, and but we are dealing with a programming customer. What do you think it matters for them? Do you think it's the deep shit that they care about? You're playing the wrong game, my friend. Anyway, we are saying
Dylan. It's a
which.
Lisp.
Oh, I never
Well,
heard of it.
Dylan. Yeah, it's a Lisp, but it actually has a surface syntax that looks more like a traditional programming language.
That's what I'm talking about. And just an asterisk, the fact, like, I think we already talked about this in this book. The fact that you have languages that live in an ecosystem and you can easily have a swapsies of like a cursed language and a less cursed language. I think that's a plus and a minus at the same time because that makes it a plus because that opens the door for people to experiment with the less cursed language. But it's a minus because that makes it an easy scapegoat to not learn the less cursed thing and keep using the more cursed thing.
Yeah, I've seen some closure code that really looks like it was written by Java people, and you can tell because it's not idiomatic at all.
Exactly. And the same goes for C sharp and F sharp. If you decide to go whole hog and produce a right thing product, you may have too much of an engineering commitment, certainly in terms of effort put into the product. If the product is not right, it will be too large and complex to modify to be in line with customers' needs. So the very investment you might have thought was the way to put distance between you and the possible competition by making the effort for entry too great is the very impediment to modifying your product to be what customers need. So this is essentially saying uh, either you are very certain about what the fuck the customers want, or you're gonna have a really bad time, really bad time, because it's gonna be expensive to do the modifications. When you release a modest product first, however, the sheer amount of typing necessary to adapt is small, and therefore can be done quickly, which means that your company is making rapid transitions in the marketplace, transitions your customer may require. The ideal situation is that your proprietary value is small compared with the total size of your product, which perhaps can be constructed from standard parts by either you or your customers or partners. Yeah, this is really hard though. Essentially saying that uh, there can be a lot of worthless product spread around, and the piece that actually matters for you to survive is small. That's tough. That's tough. Because first,
Yeah,
how are you gonna identify that? Are you gonna make it all and then see what happens? Try and error. You're gonna have some guesses based on I don't know customer research or statistics.
I
But
think
come on.
actually a bigger part of the point is that okay, you can have other stuff like below you as long as you didn't build that. Like it's constructed from standard parts, like it's a library or something, right?
Yeah, yeah. And then no one ever made money by typing. What this means in our context is that you cannot try to build too large and too complex product by yourself. You need to get parts from other places if your product is complex, and you must make your value clear and apparent, and it must be a simple decision for a customer to use your technology. But this has a very gigantic trade, man. A gigantic trade-off. You are relying on the third parties to do their job. In particular, do their jobs properly.
Yeah, that's
So, because you don't want to have that responsibility yourself, because that will make too complex. So you're gonna make you do a partnership with a third party to make that happen. And by doing that, well, we all know what can happen. If you go out with a product without cachet, you might not like the results. Cachet, a word whose meaning has changed recently to include the characteristics of having a positive or desirable aura, is what will attract your customers to your product. For example, Netscape has cachet because it is hip window into the web. So this is basically the shininess, right?
yeah.
This is how shiny it is. So like
It has alternate
the
colors
website
and
is
it
pretty.
sparkles.
Come on, let's use this programming language. Come on.
It's shiny, but it's not really shiny in the sense of it's literally shiny. It's more in the sense of reputation, I guess.
Eh, I don't think the reputation is way deeper than what I think this means. I think this literally means shininess because it's superficial, it's easily marketable, and it's misleading potentially. It's aura, man. Aura. Reputation usually has evidence. Cachet is what is that which makes a system or language attractive over and separate from its objective features and benefits. It's why kids ask for particular toys for Christmas. There is nothing wrong with your customers acting like kids or bugging their parents into buying them your toy. Cachet is how you appeal to your early adopters, whose success paved the way for acceptance into the mainstream. For early adopters, technological innovation is enough, but you should make sure that the cache is technological only and not based on overwhelming mass of technology. I use the term acceptance group to refer to people who must accept your product and technology in order for you to be successful. At first, they are the early adopters, later the mainstream. The larger you want your acceptance group to be, the lower technical skill level you have to aim for. This makes perfect sense, right? So if you're a
Yeah.
customer if in the acceptance group you have a 17-year-old and an 87-year-old, that range is gonna kill it. Like it needs to be lower skill set as possible. This is not a matter of elitism. It's a matter of mathematics. If you aim for a lower technical talent group, you have to provide a simple habitat. Again, the inertia thing, the thing that is I'm already used to this.
Yeah.
A bunch of UI and UX elements are based on this principle actually. That's why when you see a cog button, you kind of have an intuitive understanding of what that means. There's nothing written on it, but if you click on it, there is a particular set of expectations that you have.
Yep.
Furthermore, the larger the acceptance group, the smaller and lower power the computer. Well, this is not true anymore.
Actually, it
Uh,
kinda is.
outside of huge deal applications. So we're talking about smart fridges. Like we're talking about like these type of stuff, like microcontroller stuff. Aside from that, I don't think this applies.
It does. It's not saying that it will be small in the absolute sense, only that it will be smaller than what you would expect from a more focused group.
Smaller and lower, I guess. The less technologically advanced the target acceptance group, the less likely they will be to upgrade their computers unless there's specific reason to do so. Well, we can see this in games, right?
Yeah.
Yeah. It is unlikely your system will be the ultimate reason. That's true. It's unlike well, there are some games actually that people actually buy new computers for them to play. But those games are
Yeah, but they are
rare,
they are kind of rare, as they should be.
as they should be. Nevertheless, any acceptance group needs to see that your system has the right mythos, the right cachet. That their first impression must be good in order to generate word of mouth. So it must have visible value right out of the box. If your system has a lot of complex functionality, it will be difficult to make sure that the first look turns into a good first impression. The less functionality it has, the more controlled an initial look the users get. If you provide a free or cheap implementation with sources, then you might add a wizard component to your acceptance group, adding not only a free development arm but also cache. Yeah. So blah blah blah. Yeah, this is not saying anything new. And now we're going to talk about the natural selection thing, which is also huge from Gabriel, in my opinion. Recall that Andrew Beastock invoked evolution. The net effect shows that the forces of capitalism are much like those of evolution. The fittest survive. The popular idea even today is that evolution operates by making improvements. And I know we are reading a lot today, but man, this chapter is a banger. Come on. I can't just jump those parts. Come on. Uh, Darwin himself recognized that the effect of natural selection in making improvements was local at best. Darwin was writing his work when Britain blah blah blah. The theme of his theory is wedging out another species through competition. And this is what Beanstalk believes is happening. Yeah, so I want to emphasize something. The popular idea even today is that evolution operates by making improvements. Remember that. And I want to coin this understanding as more like as evolution as a positive force. It's a force that is generating something, enhancing something. Okay?
Yeah. Okay.
That will matter later. To respond to the pressure he was facing, Darwin came up with his wedge theory, which stated that the panorama of life was chock full of species occupying every ecological niche. Each niche was like a wedge, and the only way that a new species could find a place in the world was to edge out another one. And the way that happened was by being better somehow. Undoubtedly, this happens with many cases, but usually only in cases of small local improvements. For example, the human brain has increased in size since the first appearance of Homo sapiens, and this happened because a large brain had advantage, and so population dynamics selected for this trait. Perhaps only early men and women preferred to have intercourse with large-headed members of the opposite sex. And then we go to the recursion. This is Bellani's argument, okay? This is his cup of tea here. But this cannot explain how a large complex brain came into existence in the first place. Until something like a brain, only smaller, reaches a certain size and complexity, it has no purpose and doesn't really do anything. Therefore, no selections are based on it except ones irrelevant to its ultimate use. This means that there was no reason not to grow increasingly larger brains. Maybe such a brain simply belonged to someone more attractive. Eventually, some environmental change occurred in which the large brain, just waiting for something to do, had a new purpose, language for example, and its usefulness started to dominate natural selection. So this is the first entry in what I like to call Gabriel's understanding that natural selection is a suppression force. It's not, we're going to go through more, but just to do the contrast with what I said before, this is a generating force, a positive force. And what we are about to read is a reverse role of that, because it's essentially saying that natural selection is suppressing a suppressing force, a negative force, because it's going to kill the changes that make it worse. And that's something right there. To get to the point of understanding why brains can't just have grown and grown, we need to look at mass extinctions. The best known extinction was that of dinosaurs. They overlapped with mammals for by 100 million years, plenty of the time for any wedge-related competition to have increased the mammals' niche or even forced out the dinosaurs if the mammals were so much better than dinosaurs. However, it took a disaster to dislodge the dinosaurs. The small mammals were able to survive the cloud-induced winter or the flash-induced heat that resulted, but the dinosaurs were not. The mammals had something that enabled them to survive, and almost certainly it was something marginal or irrelevant until the catastrophic event. Otherwise, you have to believe that evolution operates by the future influencing the past. So again, natural selection is suppressing the dinosaurs. It's not it's not generating mammals that are superior. It's suppressing. It's removing. And that's what I think it's this man, this part was very well written because it starts by a very commonsensical definition that is a generating force, a positive force, and then there's a twist in the end saying that actually that's not how that works. Natural selection is a mechanism to reject changes, not to establish them. In fact, natural selection is used to slow down changes in the areas that matter. If a particular wing structure works, you don't want to try changing it. Therefore, those parts of an organism most central to its survival mutate over time the most slowly, because natural selection is a suppressing force. In fact, biologists use the rate of mutation to determine whether some puzzling organ or structure has a purpose. The higher the rate, the less important purpose it has. Like, come on, man, come on, isn't
Yeah, this
like
is it's a great point, actually.
like it's reversing the common understanding. I'm not saying this is the scientific understanding. I'm saying that I would bet money that most people would agree that this is what natural selection is. But what actually it is the opposite. Damn. Only things that are relatively worthless change rapidly and dramatically. These worthless things provide variety, and someday an environmental change can make one of those changes or a related group of them important to survival. Then that one or that group would join the ranks of the natural selection protected, and perhaps some formerly static parts may no longer be essential and can begin to change. Genius, genius. Like, am I going crazy? Am I overstating how great these 2 pages are?
No, this is really good.
Yeah, man. That's why I told you yesterday how excited I am. How much of a banger this ends. Fuck. For example, we use tires for automobiles, but in Africa and India, where cars aren't so numerous, people use them to make sandals. If a disaster occurred in which cars in the industry disappeared, car tires might thus be used to shoot people. Nothing in the design or intended purpose of tires had anything directly to do with sandals, but quirks of the new environment makes them useful for the new purpose. Then, perhaps, tires could begin to be improved for the new use. And then he suggests a book, which I already added to my shopping list, that talks more about natural selection as a suppression force. In other words, natural selection provides very little incremental improvement. Rather, almost all dramatic change occurs because the environment changes and makes the worthless invaluable. I think that this works in the marketplace as well. The simulation-based mechanisms of Smalltalk still are useful, but Smalltalk's success in the mid-90s as a business-oriented language stems from the use of those mechanisms to model naturally, not simulate, simple business objects. Was not one of the Smalltalk's design goals, yet it has turned out to be the key success factor, which is crazy. Like, you are not aiming for that, and because you hit that by accident, you actually had some degree of success. How
Yeah.
crazy is that? Population dynamics also make a difference. Dinosaurs coexist with mammals for 100 million years, with the rat-sized mammals making no headway, and nothing about mammals forced out the dinosaurs through competition. The lesson is to put your small technology nugget, not typing too much, and wait to see whether the environment changes so it has an interesting new use for your nugget, and then change your product to take advantage of it, and how it's used. Make a small, simple wing, wait till flying takes off, then build a flying machine. While it's flying, and that's the key also.
Yep.
Um, and he talks more about the Japanese cars, I believe. Yeah, Japanese products. Uh, More talking about the conservatism in product development and the difference between the Japanese and the American engineers. Americans spend with the same problem would spend much more time and money pushing the scientific level of the technology to a design point where it is clearly superior to proven alternatives before introducing it. In all likelihood, their costs will be higher and the risk of program slippage greater than the Japanese approach. No one ever made money by typing. And then we go with the epilogue. So we are 1 hour and 13 minutes in. I think this is pretty good. I was expecting at least 1.5 hours.
We may get there.
Ah, come on, epilogue is only 2 pages. This can't be that much. Okay, so what would you say is the most important parts of the epilogue?
Most important parts of the epilogue. Um, the most important parts of the epilogue.
Yeah, he's just making like closing thoughts, like people build computers, write programs, a person's harmed when a bug occurs. Like this is just a closing thoughts, but I don't think there's necessarily a pearl in the epilogue. I don't remember at least.
Rivers, they have water in them. uh, yeah, he brings up the whole thing about river engineering, right? About it's a big thing that you can't model, you can't fully control or understand, but you try to engineer it anyways, and that's
Actually, there is a pearl. This phrase: engineering is a discipline that fosters creativity to contrive means to a goal. This is a very elegant definition for this discipline. Um,
I like that definition actually. That's a really nice one.
and then he go up talks about the river engineers. I think the river engineers we should talk about them. When we think about engineers, we think of bridge engineers or the people who design the physical structures of skyscrapers, or the person who built a ratio out of a box of wires, resistors, transistors, power supplies, and capacitors. Those are the usual engineer roles that you think about. But then he proposed to think about river engineers. Yeah, I actually remember. This is a pearl. Uh, the Mississippi River has a broad floodplain which floods many hundreds of square miles along the main course of the Mississippi every few years. And the course of the Mississippi changes from time to time as erosion and climate related forces change the river's equilibrium. The Army Corps of Engineers is asked to harness the river and to control 20-year floods. A 20-year flood is a flood so great that it appears statistically over 20 years, over only every 20 years. And so that rich flood plain could be planted and harvested so that the homes and towns and cities like St. Louis could be safely built so that the river would stay in its banks and remain navigable. To do this, they built control structures that use the power of river flow to dig channels deeper, build dams, release points, bulldoze higher levees. And it's mostly worked, though in the early 90s, a series of heavy rain years caused catastrophic flooding. And the question was whether the river control structures made the floods more destructive than they would have been without them. So they were asking themselves, did we make this thing worse? Like, gentlemen, did we make this thing worse?
I mean, that's fair. That's a fair question.
That is, but that's kind of like hilarious and sad at the same time. The river cannot be tamed because we cannot control everything about the river and the weather. Worse, we cannot even model or mimic or understand well enough how the river operates to predict how it will behave. So how can we control it except by applying large control structures and continually repairing them as the river eats and picks away at them? River engineers are engineers who do their jobs by trying to model small parts of rivers in idealized and meteoralized laboratory mockups. One moment. By building control structures and by repairing them when they inevitably fail. This is not the picture we are accustomed for our other engineers. So essentially, the river engineer is an engineer that cannot do his job fully. He's understanding that the situation will be inevitable to predict is what puts him into a situation that he must not finish.
He's doing the best he can.
Well, that's nice. The river is human nature and human failings, and it runs through software as does nowhere else in human endeavors. The salt sweet tears, the edgy new love affair, the first birth, the exhaustion falling on exiliation, frustration, anger, the kicked heart of rejection, and all the word of life finds its way into the lines of code, the designs, the architectures, and framings we find essential to running our system of life in the political and economic world. We cannot test the river, we cannot model it, we cannot understand even the smallest part of it to the level of science in high school chemistry. And because the river and the warming and the cooling of earth cannot be figured, because the man and woman and the loving and hating cannot be figured, some engineers can only build hope and in the end repair. What a way to finish a book. And that's the end. That's the end of Patterns of Software. Whew. Okay. So thoughts. Thoughts.
Rivers are in fact made of water, among other things.
Rivers are in fact rivers have in fact water in them. Damn.
Yeah.
Um, yeah, no,
I'll
this. Go on.
I'll say this again. I said this a few times already. This is a great book.
I think it's great. I would recommend. I would not recommend it for everyone because not everyone can understand the whole thing about the quality without a name. That's a
Yeah.
reality that you need to accept. Which, by the way, I read the beginning, the forward, and I discovered that Alexander actually solved the problem. I think I even commented that in the chat. Alexander solved the quality without a name problem. The issue
Did he?
is that it took 4 books to describe it, and they are all expensive where we live.
Of course, there are always more books to read.
Yeah, so I think he even mentions in here the nature of order. That's the series. The problems are solved. So, like, what the fuck? What the fuck? What are we waiting for?
Yeah.
But apparently he he cracked it. He got him, got him.
He
So
cracked the code.
yeah, so that's something that we missed. I don't know how. Well, I know why we missed. It's because in the beginning we didn't know the weight of that, and now we do.
Well,
Uh,
hindsight is 2020, as they say.
exactly. So I would say the book is great overall. I would recommend most people that care about, actually everybody that cares about programming should read it. If you don't care about programming, like in a way, if you don't see it more than just a job, you're not going to understand this beginning. You're not going to understand a lot of it. Um, I would say that this is a banger, and this is a banger. Everything else is kind of okay, I would say. Would you agree with that?
I don't know. I kind of appreciate the story time, to be honest.
It's not about not appreciating the story time. It's not about being bad. It's about a comparison. Are you telling me that the story time even comes close to the beginning and the end?
Nope.
That's what I'm talking about. Like it's very unbalanced. The weight and the epiphanies that it gives you by reading the beginning and the end is very unreasonably different than everything else. And I'm not even saying that everything else is bad. I'm just saying that it doesn't compare. It doesn't even come close. It's not close. It's not close. Which is a very bold strategy for a book to have bangers in the beginning and the end, because this means that people may drop the reading before reaching the end. Especially because the standard that you settled for yourself was unreasonably high. So yeah, that's my take on it. So anything else before I finish the recording?
I think the right what we do section is also pretty nice, although it's very short.
Yeah, no, this is nice. Like all of the middle is nice. I would say that because the beginning and the end is so different than nice, he shot himself in the he shot himself in the foot. That's what I
That's
think.
fair. It's unfortunate, but it's fair.
Mhm. Okay. Anything else?
Should we drop the spoiler about what book we're doing next for the
No.
people who watch this?
No. You're gonna have to
Okay.
watch. You're gonna have to watch later. You're gonna have to watch later. Especially because I don't even know when they're gonna watch this. To be honest, like some people watch this, so for you, you are way behind whatever we're doing, and I'm sorry. Okay, I'm very sorry, but that's how things work now.
I mean, that's just the nature of pre-recorded stuff, right?
Not really. If I were a little bit more disciplined about posting stuff closer to the date that we recorded, this would not be a problem.
Hmm.
But
Okay.
because I got so behind the schedule, uh, it's not even close. Like I think the latest video is this.
Oh, wow. That's a lot of. Yeah, no, that's. Yeah, yeah, that's a lot.
Well, I already scheduled this to air on like next week. So yeah, that's how far. That's how far they are. Well, what, 5 videos? I don't know. We actually combine these into a single session. We combine this into a single session. So how many sessions are they behind? So one, two, three, four, five. So that's what? 2.5 months?
When you put it like that, well,
Yeah, no, we're gonna be way in the other book. We're gonna be way there, and that's okay. Like, it doesn't need to be 1-to-1 necessarily. It's fine. Anyway, I'm gonna finish the recording now.